known, has a presence online on Twitter/X, Blue Sky, Slack, LinkedIn, and is the broader community. And there are spaces to connect. There's an early career director that has early career types of tea times and meetups that happen all once a month usually is what they're trying to do. And they also have an annual conference. It's called Outlier. It's happening in June this year in Chicago. So they try to have it in different places all over the globe. And they also have an online publication that has a print version. It's called Nightingale. So that's a very great place to learn about what people in the Data Viz world are doing sort of globally and internationally. So if you have any questions about the society as a whole, I'm a former board member, so happy to talk about that in more detail. But it's a really great place to get plugged in, no matter where you are in your career in Data Viz or as a hobbyist. That is where I'm at. I don't do Data Viz for work. So anyway, let me know.
And the Outlier Conference has in-person tickets and virtual tickets.
Correct.
So if you're not going to be in Chicago, you can still attend. Data Community DC does have a Slack channel. So if you'd like to join the Slack, connect with the community, reach out to folks, see what folks are talking about, feel free to join. I'm going to leave this up here for a minute so that folks can get access to the QR code. And there also is a gallery online. So, you know, of course, we have speakers come and present their data visualizations. If you have a data visualization yourself, even if it's something from work, maybe you didn't do it completely yourself, but you like to put it online, get some more visibility, get some eyes on it, share what you've done so that others can see it. Then Data Community DC has a gallery for you, and we love more visualizations as well. So for upcoming events, the first one on here is one of the tea times that was just mentioned, coming up very soon, so you can still get in and take advantage. There's also an art exhibit in DC that is going on through Sunday. It is open late during the week, but then the hours on the weekends are a little bit different, but this would be a great time to take advantage. And then with upcoming meetups, so there's a couple happening here. You know, Excella hosts a lot of meetups, and it's great for the data community. So full stack data science, scaling text ETL and model deployment for policy analysis coming up Thursday,
Wednesday?
Yeah,
I think Wednesday, yeah.
And then Thursday, Power BI DC, again, most of our Power BI web connectors. So those will both be here in the same space. You know, food as well, so feel free to join that. Then next week, Statistical Seminars DC has the event for Vet Geo Day. This is a conference that's, I believe, the 30th and the 1st, during April 30th and May 1st during the day. I think if you have a .edu or .mil or .gov email address, you can get to that conference for free. It's in DC. And then at night, 9, so I don't know, I hope I said it. It's like a data visualization tool, open source data visualization tool. If you're interested in it or want to learn more, that'd be a good place to start learning and connect with others who are also working. Then, again, another part of the Data Community DC, another meetup, Deep Learning Adventures, having a virtual tour of Stanford, San Francisco, and San Diego. And then in May, a few weeks from now, about 2.5 weeks from now, we'll be meeting with Data Visualization DC again, and so we hope that you all come back out certainly for that event.
And that one on May 9th here is going to be a Data Viz extravaganza, nothing but lightning talks. So if you're interested in giving a short 5-minute presentation, the link is in the meetup description. We'd love to have you. It's real friendly, low pressure.
A lot of great speakers. You can still have space to join them. So I did kind of overbook us, so I'm hoping that we can go through this part a little bit quickly. But if you'd like to, so first I'm going to say that we have volunteer opportunities. So if you want to be an organizer, you're interested in joining the team like I was, then you can certainly help become part of the group, help host the meetups. It's a great way to meet people, learn a little bit more, get your feet wet with data. Also, if there are other announcements from folks who have jobs or looking for jobs or know of other meetups or things that were missed, now would be a good time to share.
Hi everyone, I'm Alma. I'm from Civic Tech DC, formerly Code for DC. It's a nonprofit and it's a group of volunteers who use technology to solve local civic issues here in the DC area. Typically we partner with nonprofits, community organizations, occasionally folks in the government, just to sort of gather our collective tech skills and try to solve problems together. We have project nights, typically a couple of days per month, so we together kind of hack on things. Always looking for volunteers. You don't have to be a coder. You can be interested in data. You can be kind of everything that they listed there. Basically, there's tons of ways you can help. And we're also having a special event June 26th that is going to be focused around climate and environment. So if you're interested in those topics, you know nonprofits who may want to join and meet volunteers who want to help around how environmental and climate issues are affecting DC. And we're also interested in open data sets that could help us learn more about those issues or probably find new projects. So anyone here is welcome to come. If anyone wants to talk about something in particular too, we can probably arrange that. Thank you.
Okay, with that, we'll then get into our first speaker.
Ooh.
So I'm gonna switch over so that.
All right. So, if you, yep, perfect. Want to share your screen?
Can you see it?
And I'm going to mute myself here. And Jamal, can you unmute yourself? Nope.
All right. Are you ready for me?
Do we have audio?
So I'm gonna test the audio, see if it's coming through.
Hello? Can you hear me?
I think that one
Let's see.
was.
Nope, I'm gonna turn that on. Try again?
Can you hear me now? Can you hear me now?
Yes!
Yeah!
All right. I can also hear me a little bit, but I think this seems good.
Trying to figure out how to do the full screen.
I guess
Anyone?
there's a little bit of echo as you're speaking. Jamal can mute as well.
Okay. Okay. Ready? Yep. Okay. Hey everybody. Thanks for having me. I'm C. I use they them pronouns, and I'm the lead for the USGS Viz Lab. That's the water data visualization at the US Geological Survey. And so today I'm pretty excited to tell you kind of what we do as a team. The main goal being communicating water science through Data Viz. And actually, I did a postdoc in DC like 5 years ago, and I used to come to these meetup groups like in the early formation of my Data Viz days. So I was kind of excited to give this invite. And so the USGS Viz Lab is a small team. We're a group of data scientists, designers, and storytellers. Everybody kind of brings their own unique skill set, from like cartography to graphic design to science communication or background in science and hydrology. And together, kind of that drives what we do. And so a lot of the stuff I'm going to show you right now is not just me, but it's the collective efforts of this group. And so the mission of the team is to bring USGS water science to broader audiences like the public through timely, accessible, and engaging visualizations. And the majority of the talk that I have here is just to show you a bunch of examples that I think are really fun, that hit on those different points. So on this team, we operate in the currency of charts, maps, interactive data visualization websites. We love making animations, and we're using a collection of skills, mostly programmatically through R, Python, and JavaScript. But we also like to complement that with design skills, illustration, as well as storytelling. Our main audience we're trying to reach is the public, but this can be done in a bunch of different ways, either through social media, websites that we do in the sort of data journalism style. But we also make an effort to develop products specifically for water managers, because we are part of USGS Water. So everything you're going to see is water related, as well as some effort in education and Congress, often kind of being a secondary audience for a lot of this work. This shot here is just kind of a grab of our the major pieces in our portfolio, which can be found at that website at the bottom, labs.waterdata.usgs.gov/visualizations. And each of these capture kind of like, if you look across them, it's a whole variety of different topics in water, a wide range and diversity in styles. And that's kind of the fun part about our team, is like we have this creative license to tell these different stories about water science, bring our own creativity into it, and just do a lot of fun things to make them really pop visually and be engaging to the audience. So most of these pictured here are what I would categorize as like our interactives. So these longer form data journalism style websites that go deep on a single topic in water science, or using a USGS data set. This has kind of been the recipe for success across these projects. We collaborate with teams of USGS researchers. We leverage our public data sources, as well as other public data sources, often from other federal agencies. Behind the scenes, everything we do is in data processing pipeline, whether that's R or Python, because one thing that's really important to us is that all of our work is reproducible, at least the data side of it. And then we also leverage tools like D3 to make interactive charts or animations, Adobe products for graphic design, and then we build our website using the Vue front-end web development framework. So I thought I could just show you a couple examples of this. So this first one, drought is a major theme for us. It's a pressing issue across the country, and so part of our mission is to make sure the public is aware and understands like what is USGS doing in this area of drought, and just how to better understand the impacts of drought across the country. So I think this one came out a year ago. This site we call What is Streamflow Drought? And so what it is a scrolly telling style website where as you scroll the page, the images and the text update. And it takes you through kind of this narrative of how could you measure drought using a USGS stream gauge monitoring site. And there's 10,000 of these across the country. And it does this kind of like slow build to kind of like layer in the story and add complexity as you go. Something I said at the beginning, we call this scrolly telling. If you're not familiar, that's the combination of scrolling and storytelling, where you can use the scroll to be able to paste the information, which just makes it a little bit like easier to go deep and get into complex topic without overwhelming the audience with too much at once. So this one is about like how do you measure drought using Streamflow data. And then we have a follow-up one where we took that method and we applied it to all of the stream gauges across the United States over a 100-year time period. And we created this 100-year timeline of drought events across the US. So what you're looking at here on this chart is each one of these lines represents a drought event, like at a point location in the US. And so the length is the duration of that drought. So this one goes from like 1921 to 1922. And then as you scroll the page, you can see, when there's more locations that are in drought, it starts to create this unique shape of simultaneous drought in multiple locations. And if you look, this map in the upper right is also highlighting the locations that are being shown on the chart. For this one, also sort of a scrolly telling style, we really wanted to layer in kind of the context of the times. So there's these quotes from, different major droughts that are folded in, and different annotations here, for example. So this is like this line represents the most severe drought throughout the 100-year period. And it kind of creates this cool little shape. And I really love this one because this is actually like a unique chart type that we designed. specifically to communicate this, like how long and when are the biggest periods of drought. And that was just a really fun project to be involved in. It's pretty long, to be honest. And then you get to the bottom here, and it has this other interactive chart where you mouse over these different regions of the US. There's a little map in the center there. It's showing you the same kind of pattern, but more as like a violin plot for each of the regions of the US separately. And so that first What is Streamflow Drought one, that actually was made the long list for the Information is Beautiful Awards last year, which was a really proud achievement for us. Other ways that we like to include interactivity into these sites. This is a website about how climate change is affecting different fish species in the Midwest. And so in the chart on the left here is like in the site, it's this interactive. You can draw and you like guess the line of what you think is happening with the walleyes that are compared to bass. And then on the right here is actually, over like a 5-year time period, we captured every single guess that the audience made. And then I've overlaid them here so you can kind of see how that compares. This visual is from a site about how USGS uses temperature data to forecast stream temperature outside of New York City, because outside of New York City, there's these really important reservoirs that are used to hold water that provide water to both New York City as well as like the whole state of New Jersey. But it also is really important ecologically for fish species. So there's really important decisions that are made of when and how much water to release. So this animation is just showing kind of to build that story. We made it of on the left, you're seeing a map of the river network of this river basin, the Delaware River Basin. And then the chart on the right has this paired interaction where it's showing the stream temperature at each of those river reaches through a year. And then as like the mouse goes over each month, it's showing the mean temperature for that month on the map. And I want to show this one because it's like we love doing these kind of like cool paired interactions where you have like a map and a chart, because often you do have the spatial and temporal context to the data. And we found this to be like a really fun and also useful way to show both of those and how they're related. Related to this one, this is a visual we actually made specifically for water managers that are making the decisions about whether or not they release that water from the reservoirs. So we have a whole forecasting team here at USGS, and they're making daily forecasts of what stream temperature is going to be. These are 5 key sites that have decision points. And there's a red line on this one because as the temperature exceeds the 75 degrees Fahrenheit, it becomes too warm for fish. Right, and so that is an important consideration of when and how much water to release. And I also just love this one because I got to use this. I can't remember it's made in R, but the kind of the confidence intervals using this blending thing I thought was really fun to do. And I guess what you're seeing here too is like the forecasts are shown in that blur with the line where the median forecast is a line, and then the white dots overlaid are what the actual observed temperatures were for that day. So using that to quality check like how good are these forecasts that USGS is making. Part of our teams, to reach the public, we do a lot of work that gets put out on social media, and a lot of consider just designed specifically for social media. One major one that we put out on a quarterly basis, we call this US river conditions, and it shows all of the stream gauge locations across the US, and then what the current conditions were at that site compared to the historic past at that site. So where it's blue, you're seeing it's like wetter, maybe there's flooding, it's much wetter than in like the 30 to 100-year record at that site. And then where it's red, there's drought. And this is all done programmatically, including like adding these annotations that come on and off to like highlight different events that happen. And this is the one just from the last 3 months, from January through March. And this is built all entirely in R using a reproducible pipeline where we effectively just change what the annotations are and the dates, and then it regenerates the entire thing with pretty low effort. Similarly, this is a chart that's actually using the exact same data, but just cut to the month of March, and we put this out every month. And so what you're looking at is a proportional area chart where the x-axis is like the day of the month, and then the y-axis is like the percent of stream gauges in each of these binned classes of streamflow conditions. So where it's blue, it's much wetter. Where it's like yellow and orange, it's much drier. And I love this one because like you can see, like if you look at the right hand side of the country here, you can see all that dripping from some sort of major event that happened in the last month. And this is again is like a style that I love to use, the geofacet, where you have like small multiples for each state. Working with data that are unevenly distributed across the US, this can be a good way to kind of pull out different patterns and look at it. This is another one that we've been putting out this spring as the snow starts to melt. So you're looking at USA National Phenology Network data. And again, the map and the chart are paired, and the color scales paired between them, showing what was the timing of the first spring leaf out across the country, and then the white line over the chart is like what that 30-year average looks like. And I just actually reran this one before the meeting, so this is updated through today. And this one also made the long list for the Information is Beautiful Awards this year. And so one of our most fun parts about our social media efforts has been, for the last couple of years, participating in what's called the 30-day chart challenge. And that's like a cross social media platform event where for every day of the month of April, so it's actually going on right now, there's these prompts that are put out that are supposed to inspire people to design their own data viz and then share it on social media. So like, in the first week here, we have comparisons, and there's part to whole waffle. There's a whole variety of topics, or maybe some days even have like data sets that are provided. And what we've been doing at USGS is sharing this out across the organization, and then bringing in collaborators and scientists from different parts of the agency. And so it's been this really fun like community building event where we have these weekly design studio, we call them design studios, but they're like design critique meetings where people come and share their sketches or their drafts of what they're working on, and rapidly put out a bunch of charts through the month. So these are the following. This chart here was actually developed during that. That was one really cool outcome from it, and the rest of these also were. So it's like kind of a opportunity just to be fun and creative and try new things. Like Haley, who made this chart, I think she took inspiration from Lisa Frank color palettes, just because she could. Why not? So this is showing the percent of water use at a county level basis across the US for these major water use categories. This one, the chart challenge has also just been an opportunity to be experimental and try weird things. So this animation takes 100 random US lakes, and then it uses this variable called the shoreline impact factor or something like that, but it's basically a metric that tells you how circular the lake is. And so we selected 100 random lakes, sorted them based on this variable, and then have them overlaid with this circle so you can see as they go from like kind of wiggly all the way to like almost a perfect circle at the end. And this one we shared out on Reddit and actually became the front page of the Data is Beautiful page with like 1.2 million views. And we got hundreds of follow-up emails where people were pointing out what body parts the lakes looked like. This was like kind of a fun cartogram we did where just looking at like the percent of each state area, like land area that's covered in water, and then using the cartogram to animate between the two, so where it's shifting the area of the lake or area of the state to kind of reflect what that relative percent area water is. This one again is just made entirely in R, and it's a little chaotic and hard to interpret, but it's cool to be able to make something like this. I think another value added point of this chart challenge is it's really connected us with the broader data viz community, not only in like the US, but like internationally. On the left here is a chart that Lauren made, who was working with us, where she measured like what is the direction that water is flowing across these like major watersheds in the US. And so you're seeing a radial chart, north is at the top, and the bar lengths are relative to like the total area traveled in that direction. And the example at the top is this watershed in Washington that generally flows northwest from the headwaters near Mount Rainier towards Puget Sound. And you can kind of see how those arrows match up. And then, we got a bunch of interaction on this one on Twitter or X or whatever it is now, where Dominic Roy, who's in Spain, I believe, he made a similar chart using the NOAA coastal data to look at like what is the distribution of coast orientation in the USA. So it's been like this really fun, creative like experience to do. And we publish all of these in all the charts that we made. We have blog posts that we publish online that you can see the links to all of them, but we also publish all the code behind them. And again, using public-facing data sets and making everything fully reproducible so anybody could recreate them on their own. We also recently, or maybe in the last year, we published this blog post, Jazz Up Your ggplots. We have like a pretty strong R bias in some aspects, and we, through the chart challenge, learned so many different tricks that we were doing to customize our charts, like whether it was like adding annotations and arrows or using actual like images as our data points, which you can see in these raindrops. And so we wrote a whole blog post just about like, these are our favorite tricks that we use. And there's reproducible examples for each of them. There's maybe like 10 different things, how to use different fonts, how to animate things. And so it can all be recreated just by copying the code. And then the last area I just wanted to highlight is like we're kind of exploring more into the education realm and how can we help promote data literacy for students, in middle school as they're learning about water science, and have them interact with data and kind of be a part of that journey with them. So this isn't really Data Viz, but one major effort in that is we designed this water cycle diagram. We did a whole user-centered design process where we worked with 100 teachers doing this like back and forth to really align it with national education standards and create something that they would use in the classroom. And now this is one site that we have out so far, but we're continuing to develop in this area interactive Data Viz charts that kind of go with the water cycle. So this one is pretty simple. It just shows the magnitude of pools and fluxes in the water cycle from the ocean to lakes to like saline lakes, precipitation. And then on the chart, when you click on any of these points, it pops up this example box that gives you actually, like a median estimate as well as the range, a photo, a definition, all right there. And I wish I actually had this one open, or actually I could probably open it. I wish I had this one open because one thing that's really cool about it is it has this animation that, let's see if it loads. Okay. So one challenge we had with this is, oceans are by far like the vast majority of water on Earth. So how do you make a chart that you can fit that in, but also have these little small slices too, and like all that's communicated? So we made this animation where you can, these are the raw numbers, and then it transitions between a log and linear scale. And I've actually gotten a lot of feedback from teachers now. I just went to the National Science Teacher Association conference, and people are using this to actually teach like what is a log scale, which I thought was a cool and also unintended use. And then you can also turn the ranges on and off here. And that's really all I had, but there's a bunch more on our site, and I'm happy to take any questions, and I hope you guys will check them out.
Questions from the audience? This was super cool, by the way.
Yes, thank you.
Is it through your microphone or is it through the room?
I can hear you now.
Okay, cool. That was my question. So I noticed that you do a lot of, it makes sense since a lot of your business that you're sharing are public facing, that you have like state level data, but I'm curious, watersheds don't necessarily follow state borders. So do you do some of your mapping, like your small multiples on a map, do you do those by watershed sometimes for like your, WFOs, your weather forecast offices, or your river forecast centers?
Yeah, that's something we're facing right now. for example, like we deliver this like national most comprehensive data set of like how water is used across the country, and it used to be delivered at like a county level or like census tract, and now it's going to like a HUC watershed level. And so that's like a challenge we're facing, is like, how do you translate that in a way that's going to be meaningful to somebody that doesn't know what watershed they're in necessarily, right? And we have been experimenting with that geofacet style where it's the same concept. So they're spatially, like there's small multiples that are spatially located still in the same spot, but maybe the name is a little bit different. And I don't know, to be determined on how effective that is.
Yeah, I mean, I realize it's a hard question for like a very specific audience, and I think that the state borders make sense for public facing information, but just curious, like, since a lot of the forecasting that happens and things like that is not necessarily, you know, bordered by what we drew lines in the sand, you know, hundreds of years ago.
Yeah, no, it's definitely a major challenge. I think we do, if you look at our stuff too, we have a series of pages that focus on like specific watersheds. Like we have a lot that are the upper Colorado or like the Colorado River Basin, because those are like really important for drought right now. And so there's a few basins like that that USGS has selected as like, these are important basins for these topical areas like salinity or climate change and things like that. And so some of our stuff will have like kind of more of that zoomed in view, but I think, yeah, it's just kind of this disconnect of like what maybe the audience wants or thinks they might want, and then like what is sensible as far as like the data itself and the methods.
More questions?
I don't know if you can hear my question, but I know you showed a chart that you actually made that kind of looked like eagle wings to me, but it was really interesting with all the lines coming down. So I was just curious about your process of like, how do you think about exploring with a new chart and making sure that's understandable to your various audiences? Because I know you said you're trying to teach the public, but also water managers who are more technical. So I was trying to understand, like, do you have like a time frame on how much you put to exploring, so you know, like, okay, we can't explore too much, or we can't put too much on this risky chart. We need to have something that's ultimately understandable. I was just curious about your process.
Yeah, I think one thing that I love about the team is that we do embrace this like diversity in design. Like we often don't pick the most, like the more like common chart types to use. And one way that we kind of like harness, but also constrain our creativity is like on a quarterly basis, we do what we call an idea blitz. Team is actually doing one this entire week. So we block our calendars off of all meetings, and everybody just picks a mini project. Sometimes there's like a prompt like, oh, use water use data or something like that. But sometimes there's not. And everybody spends the week just doing like a mini sprint where they want to have some visual to show at the end and present out. And we'll do, you know, some like feedback sessions where you get paired and like give each other feedback and talk it through. But that's been a really great way to just like be able to do a lot of exploration and try new things, and also accept that there's a lot of failures there too. But I think like still going through that process isn't really a failure, right? But if it doesn't work out, if your idea isn't that great, or maybe it was too hard, at the end of the week, we can just like set it aside, and that's fine. And some things like that chart that you mentioned, that actually did come out of that, and then we ended up doing this whole site about it because we thought it turned out pretty cool.
Thank you.
Okay, so the math teacher in the room, we're doing logs and exponentials right now. So I'm delighted, and I'm going to go and I'm going to move around in this tonight and see what I can do to make it useful, to give it as a visual display. The question is the USGS site searchable by math topic? I know you said you're starting to reach out more to educators. It would be really quite useful to be able to say, okay, once we're done with this, we're going to be dealing with radical functions. Hey, I'm going to go to the USGS site and see if there are things in there that I can use. She asks with her fingers crossed.
It's not set up in that way, but honestly, just email me, because USGS does, we have this like youth and education science program, and they do have a site that's kind of in the early stages where they're collecting like different kind of data driven lesson plans. And we have actually hired, we have like, right now we have 2 what they're called Einstein Fellows that are teachers that are embedded in this government role for a year, and they do projects. And they've been very focused on like engaging students with data in the classroom and building out the site this last year. And I will also say, like, one of our projects we're working on right now, we call like the working title is like the climate chart gallery, but that's kind of the idea where you would have all of these different charts in one big collection, and there's all these different keywords and tags that you can sort them by. I didn't think of like the math angle, but that would be a really cool one because we are thinking about how we can pair that with different lesson plans as well.
Great, thank you, yes.
Well, thank you so much for coming and sharing this with us. My sister's actually a civil engineer who does water resource management, so I'm going to send her all of these right after this.
Awesome. Yeah. Thank you so much for having me. Feel free to add me on LinkedIn or, email me if you want to connect.
Thank you.
All right, who do we have next?
Your cell phone is yelling at you because there is a tornado or a hurricane coming. That is coming from us. It's coming from the National Weather Service, which is part of NOAA. So we're a big agency, and one of the things that we do is education. And so the Science and Street program is part of the Office of Education, and I'm going to show you all the things that we do. Okay, again, NOAA. First, very simple, our mission. Our mission is 3 words. Science, service, and stewardship. So that's very important for us, and that's, I think, why we have a very strong focus into informing the public, educating the public, because that is part of our mission, the service. We also have a couple of things that we always say. The NOAA's mission is protect life and property. That's a very noble phrase, I will say. We are always there, and we have a lot of respect for the people that work in the National Weather Service. I wouldn't like to do that, but they do it, so awesome. And we also have this kind of our motto, from the surface of the sun to the depths of the ocean. That's what we do. Believe it or not, NOAA is also looking at the sun all the time, not only NASA. Great partners though. But we also look at the sun. Why? Because there's something called space weather. So if there's a big CME, a big explosion on the sun, a big flux of solar wind that's going to affect the Earth in terms of it can affect satellites, it can affect the power grid, it can affect planes, GPSs. NOAA is the agency called by law to provide those warnings. So we always see like NASA is the people who's doing a lot of the research, they have a lot of satellites there, but the operational side, when something bad happens, then it's us who has to provide those warnings. Okay, and I want to show you one of the things that I do and we do as NOAA. So that is the visualization of the just recent eclipse and from one of our satellites on space. So we have several satellites in the space. I think more than 20 satellites from NOAA looking down at the Earth. The other side of those satellites look at the sun. So for example, we can get that data. And why do we have those satellites? Because weather is something that happens at a global scale. So we need that data. We need all the global the globe covered by satellites, and we cooperate a lot with the Europeans and Japanese to get all that data together, because that's how we provide the services that we do. And now let's go to this. Now a little bit more about the science on sphere. What is the science on a sphere? So it's pretty interesting. Probably you have seen one of these. Actually, we have one science on a sphere, which is a 6-foot carbon fiber sphere suspended from the ceiling that has 4 projectors shining on it and projects global data. So one of it is actually in the Smithsonian here, Natural History. It's in the Ocean Hall, and if you go there, you can see one, and we have actually 200 of those around the planet. But we are not only about spherical spheres. We actually have software. There's the SOS Explorer that I'm going to be talking a little bit more now. And we also have a mobile application that you can download in your phone and have basically all this kind of data in your phone. Now, as I mentioned, we have 200 of the sphere. We have 50 installs of this Explorer specifically for museums or science centers. And we have SOS Mobile. This has more than 50K downloads in iOS and Android. So these are the places where we actually have spheres. We have around 100 in the US and 100 abroad. So we have a very good coverage. And I think these institutions serve around like 70 million people in a year. I'm not saying that 70 million people look at our sphere, but they serve that number of people. So now a little bit more, if you want to see more about our catalog, you can scan that QR code there. But one of the biggest things that we have as a Science on Sphere program is our catalog of data sets. We have 600 plus different data sets, all about Earth information, not only about information, but they are all displayed as spherical display systems. So that's, I think, something very, very different that you are familiar with. We are not about charts, we are actually about spherical data, or the spherical visualization of data, which is very, very interesting. So we have single pieces of data sets. For example, we have clouds, we have temperature, we have ocean, we have currents, we have a lot of that. But we also have movies that talk about different topics. We also have a lot of material from NASA. Actually, Mark is sending us all the time, and you're gonna hear about his work, but he sends a lot of things our way, and we also publish in our catalog. So we have a very, very, very large catalog. That is not always a good thing, because sometimes it's really hard to find something that actually matches what you want, and that's something that actually we are working with LLMs and AI now, trying to kind of create a chatbot that will select automatically the data sets that you should use for a specific topic. That's something that we're trying to aim for the end of the year, where teachers can actually ask about educational goals or specific standards that they have to fulfill, and then the AI will produce a specific subset of data sets that they can use on that topic. Now we're going to be doing an SOSX demo, and as you know, live demos are tricky, so crossing fingers there. But if you want to scan that and get our application in your phone, it's completely free. I will say that be careful with the data. Just download your things when you are connected to Wi-Fi. But all the data is completely free. We never charge for that. Anybody in the world can use our data. So let's go there.
And there is Excella guest Wi-Fi, just Excella guest.
Okay. So this is the kind of visualizations that we work on. So this is actually visualizations that is showing, the name is clouds, real time. So this is a very interesting visualization because we're working with data that goes from 30 days in the past to literally today. So for example, if there's a major event on the planet, like a hurricane or an atmospheric river going to California, you can track that live with our software. So this is actually gonna be released for desktop very soon. So this is kind of the test, so that's why I'm crossing fingers. The mobile application is completely free. It's functional, so you can download it right now, but we're working on something for desktop that's more directed towards teachers. So we're trying to aim for that audience with this. Now, I have a question for you. I know you like to answer questions. Why there's no night there? This is going 1 month. Why there's no night? Why there's no shadows? Why?
Radar.
Radar, and it's not radar.
LiDAR?
Not LiDAR.
Because it wouldn't be fun to see it flashing.
I'll take that one. It's actually because our satellites, the geostationary satellites that are following the planet, they have many different detectors. So we have dozens of detectors in our satellites. One of them only detects clouds, and that's the data that we're showing. This is not a picture of the Earth. The background is just a generic base map that we use. We are only showing clouds. So that's why we have that. Actually, we also have the real view of the Earth, the true color of the Earth, which is the one that I used to create that visualization of the eclipse that we have. We also have that. But for example, this is something a little bit different. And if I open the catalog, you can see all these other real times that we have. Like, for example, our colleague just a second ago was talking about drought. This is a real-time drought map. It's going to be showing points where drought is being reported all over the planet. And the interesting about this is that you can just move around the planet. So this will show every single point on the planet. And if the developers did a good job, you should be able to see it as a 2D too. So not only as a 3D, but as a 2D if you prefer that way. As I mentioned, this is going to run from 30 days to today. We also have longer term visualizations in terms of real time. For example, we have snow and ice, which is going to be focusing on all the snow ice on the planet. And we can see the seasons happening there, right? The summer and the winter, how the ice expands and contracts. And as NOAA, we are not only providing visualizations, every single piece of data that we are projecting there is being archived at NOAA. So NOAA not only produces visualizations and forecasts, we also archive all that data because we use it afterwards to improve our models, we use it for historical trends, we use it for analysis, and all that data, same way as everything that we have real time, is completely free and available for anybody to use. So now moving from the real time, we can go to a more extensive show. This is only have like 150 of our top 150 data sets, I guess. Something that I want to show is about climate, for example. So we not only have historical data or real-time data, we also have models for the future. So this is one model that we are working on with SSP tools. So first, a model, you know, is just a bunch of equations that you put in a scenario on and it's gonna give you an answer. So the scenarios that we're working on are the newest used by the IPC, which is the UN body for climate change. They have different scenarios, and SSP2 basically is we are getting better. So we are changing our ways, we are ditching a little bit of fossil fuels, we are investing a lot in neolics, and this is what the model tells us that's gonna happen. So this is not a forecast first, so we're not saying as no, this is exactly what's gonna happen here, no. But this is a guess from the models that we have, okay? So something important to notice, for example, is the colors that are changing all over the planet, and we can see that the North Pole is definitely the place that is gonna be changing the weather the most. So now if you see the high range on the data goes to 11 Fahrenheit or 6 C. And again, this is we changing, okay? So let me show you the one that we got for we don't change, which is what we are doing right now, basically. So alongside in the data for this, for example, we have the parts per million of CO2 that we have here. In the previous simulation, we end up in 2100 with 590 something parts per million. And this one, we blew that in the 2050s. So this is SSP5. SSP5 is business as usual. So we are not changing. We are just doing what we are doing currently and crossing fingers, basically. And let's take a look at what happens in 2100. So I'm gonna pause it over there. And I have to say that, unfortunately, this visualization is not correct there. What is the problem? That when we create this visualization, we said, oh, let's start from -6 to 6. Nothing's gonna go beyond that, right? Actually, it does. So there are several parts here that they go all the way to 12 Cs. And actually, we are reworking this visualization to introduce that color palette there. I know it sounds terrible. I'm not bringing good news, but this is what we do. This is what we try to communicate. And we are not always just showing bad things. So I'm going to show you a couple of the things that we try to show in terms of education. Okay. So this is education, isn't that right? So this is something that we try to use very commonly because we don't want to leave people thinking on a red ball there's a planet, right? So and we know that's going to happen. So as an organization, NOAA understand that that is what is happening. So it's not a future, a long future where climate change is going to do things. Climate change is happening right now in our communities, in our states. That's what's happening. So what we are thinking is about resilience. So what is resilience? The idea is that we know that things are going to happen, that we are prepared for them, that when they happen, we can face them better, and after they happen, we can go back to normal quicker. So that's the idea of resilience. Every single piece of this actual very interesting cartoon has sections where people is doing things that are making their own communities more resilient. And we try to show that because the whole idea is climate change is here, it's coming, things are gonna get worse before they get better. So we have to be ready. We cannot just wait in with crossing the arms and waiting for a solution. We have to make our communities more resilient. And that's the idea of the whole framework that we are thinking about the weather in terms of NOAA, that we have to be ready. We have to be a ready nation, basically. And that means that we have to be resilient until we get a solution for climate change. And that's definitely crossing fingers. But in the meanwhile, we definitely have to be better in how resilient we are. Okay, now let's go back to the presentation. Okay, so another thing that we are trying now is, as you have seen, we have several data sets that are basically single pieces of data. So we have one for clouds, we have one for temperature, we have one for CO2, we have all these things, right? But now we are definitely pushing hard in terms of getting those together, like in topics. For example, something that we started was how the pandemic was affected by, how air quality was affected by the pandemic. So that was very interesting. It's right up in our alley. We take care of that. We don't take care. We observe the atmosphere. So we had all this data about what happened during the pandemic, especially the lockdowns. So if you go to this very nice story map, you're going to be able to see it. I'm going to just show you a summary of it. And we developed several different visualizations to show that. First, we visualized the cases, how it started in China and basically wrapped the world on number of cases. Then the next one is actually the lockdowns, the response, the social response to this. So what happened in different countries, how it was responding. And the degree of the color there is how restrictive were the lockdowns. Then we moved to something a little bit more local, like trying to show those changes. So one example there, and this is a very nice slider if you can access it on the web, is actually the Walt Disney parking lot. Before the pandemic, it was just completely full, and during the pandemic, it was completely empty, right? And then we added one chart because, of course, one chart is always good. Mm-hmm. And this chart is basically just comparing the consumption of gasoline versus diesel. And we noticed that there was a very interesting dip in gasoline, but it wasn't the same dip on diesel. That's why, because the trucks had to still move, the ships had to move, trains had to move, people wasn't moving. Like private cars were moving. So that's what we found out. We also made a very nice visualization about shipping trucks all over the US, how that changed before and after the pandemic. And actually, surprise, surprise, didn't change a lot. The only thing that we found is there was a lot of swirls close to the ports, which is basically just the ships waiting to be unloaded, but other than that, we didn't find a lot. And then we went through a lot of things. And we, at the beginning, we entered this saying maybe there was an effect in CO2. And there wasn't. So all those years that actually we were between lockdowns and stopping and not doing a lot of things, didn't have an effect at all in the CO2 measurement at the end. So I think that's, again, not the greatest news for everybody, but that's what we found. Now I'm very close to finish. A couple things I want to mention before. As I mentioned, we are working not only in visualization, but we're trying to improve our access to the data that we have through LLMs. So AI, we're working a lot in AI and trying to create a lot of different applications with that, so our things are easier to be found, easier to be applied to different topics in different audiences. And we're also working a lot with XR, so VR, AR. Something very interesting, for example, you can imagine our beautiful, amazing sphere, but we cannot visualize anything beyond that sphere. We cannot visualize satellites because everything is being reflected on top of a surface. So we cannot visualize satellites going around. We cannot visualize the rings of Saturn, for example. So we're actually working on VR applications that you will hold your phone into the sphere and you will see these additional layers of information through VR. We also developed, we're trying to use VR to go for this, I would say the holy grail of our field, which is global to local. When you see the planet, and we see it every day, you see this beautiful blue ball and everything, but you don't see, the thing that you don't see is you don't see us. You don't see our effect on the planet. And that is sometimes problematic because when you see that beautiful ball, everything is okay, everything is beautiful, but we are changing it. So we're using XR, or actually VR in this case, to visualize that kind of change. Something that we did, for example, is NOAA has campaigns for urban heat island. I don't know if you're familiar with that. Urban heat islands are basically the difference of temperature in the same city at the same time because how they are constructed. Like places or neighborhoods that have a lot of tree coverage and they don't have highways or big parking lots are gonna have a much lower temperature. The other places that have a lot of highways and a lot of parking lots and very few trees. So that's something that NOAA is looking very, very close to because, for example, for DC, where the official temperature in DC is measured in the airport, DC airport, which is basically outside DC first. Second, when, for example, it says 95 in summer, there might be places in DC that are 105 and other places that are 85. So that's a huge difference. Maybe there are places in the city that should be under a heat warning and they are not because we are only using the temperature on the airport. So we're actually looking at those problems and how to solve it. And one of the first steps is actually visualizing that. So we collected data for that and we actually create a virtual reality experience where you can fly over DC looking at the data and looking how hot is your neighborhood, how hot is your house, compare that to other neighborhoods and have a little bit of an idea of how this affects your own city. Okay, so now the summary. First, science to the service of people. I think that's very, very, very important for NOAA. Everything that we do is to protect the citizens and the property in the United States. That's our main goal, and that's what we do. The Science on the Sphere offers hundreds of visualizations. And I have to say, every single visualization is completely free and available. We're also trying, as C was mentioning before, we're trying to replicate all our procedures. How did we create that visualization? What software did we use? Publish our code and publish the underlying data. So we're trying to be more transparent how we do that too. Second thing, we are soon to publish a free version of SOSX. So if you want to know about that, send me an email. Probably it's coming in 2 months. So if you want to download that, let me know. I can send you an email after that. The mobile version is completely free and available right now. Now, something important for us, the data and visualization are not information nor education. I think that's very important. Not because we create a really nice visualization means that we are informing or we're educating. There's a big gap between that. And that's sometimes things that, especially in our own organization, scientists don't realize. They believe that this beautiful chart or this amazing model they create, everybody should understand it. And that's not the case. We, as part of the Office of Education, we work with those scientists and we try to distill all that knowledge, all that information into something that people can actually understand, and especially understand why it's important that we do that. I think that's the main thing, why we should care about clouds. And it's not just, oh, clouds are beautiful, but they control our weather in a big manner. So it's very important for us that people understand why are we visualizing these things and why they are important. And that, definitely know your audience. Like, who are you producing this for? I'm not saying that our visualizations are for everybody, because they are not. We are definitely a science education center. So the visualizations that we produce, and we have a disclaimer on our website, they are not research-grade data or research-grade visualizations. They are educational visualizations. We always have the underlying links to the data, and if people want to go deeper into them, and we offer that. But our goal, our audience is basically education. And why is that? Because how do we do that? The story is at the center, and science as the scaffolding. That's something that we're trying to get our heads into, that we don't have to publish the science just because the science. We have to publish something that's interesting and use the science to enhance it. For example, one big example, we just met with a lot of scientists that are working on climate change in the Pacific, close to Hawaii, and they want to talk about that. And we were exchanging ideas, and we landed into they are going to be developing everything about one single fish species. They're going to be talking about that. They're going to be talking about their life. They're going to be talking about their cycles, their migratory patterns, and everything. And they're going to be using that to underlie different things: currents, climate change, microplastics, and all these other things that the scientists really, really, really care. But if you present as separate pieces to an audience, they are not going to care. If you have something that's charismatic, interesting for people, they're going to acquire that, and they're going to get the science with it. And that's all I have. So if you have any questions, please let me know. If you can send me an email, or just as you can add me at LinkedIn. And thank you very much for this. This is my first meetup ever, and it's been great so far. Thank you. I don't know if there are any questions.
We have time for one question, I think.
Okay, I think we're good.
That was one question.
Juan Pablo.
Go for it.
Great talk. So,
thank you.
The climate breaking your data visualization. So I just want to dig into that a little bit more. How are you getting? So one of this happens to us all the time, right? So if I want to scale everything to the biggest change, then I actually wind up reducing the effects of what's happening now.
Yes.
Right. So what's your philosophy on how to deal with it?
This is something that we did after the fact, actually. So we created many different visualizations for many different scenarios. So we have SSP1, SSP2, SSP5 for 5 different variables. So we have like 15 different visualizations out of that. And after the fact, we noticed, I reviewed the data for SSP5, and I found that many places we blew the range. So what can we do about that? So again, this is after the fact. So instead of trying to redo all the visualizations which are already out there, and that's our main why not to redo all of them because they are already there, is instead of changing, and as you mentioned, just broaden the range and using the same colors, we wouldn't make that comparable to the others, first. Second, if we change all of them, as you said, the small changes will disappear. So what we are actually doing is to the existing range that we have, we're going to be adding extra color just to make that portion that we already did comparable to the other 15 data sets that we have. So this was actually kind of building the plane where we fly kind of decision, but that's the best decisions that we found. It's not ideal.
If only we could see infrared, we would.
Yes, and we're going to be sharing that with you, and that's something that happened after the fact. Probably if we would have just gone beyond the idea, oh, nothing is going to go beyond 6, we will have found this before, but sometimes that happens. So that's how we're dealing with that. Okay, thank you, everybody.
So who wants to go to a field trip to the Natural History Museum to actually see the spheres?
Yes.
So speaking of Data Viz field trips in the future.
You just wait till October.
October, okay.
What am I doing now?
1 second.
Ooh, map clicker. Ooh,
We'll try it.
map laser clicker.
We'll try it. All right, hi everyone. My name is Alex Gurvich. I'm going to continue the federal government extravaganza, I suppose. I'm a visualizer with the Scientific Visualization Studio at NASA, also the technical lead for Earth.gov. I only found out that my supervisor was going to be giving a quick talk today, a couple days ago. So you'll probably hear more about the Scientific Visualization Studio. I don't know what you're talking about. All right.
I thought you'd cover that.
Okay, well, between the two of us, you'll have an idea of what the SVS does. In particular, what I'm going to focus on is the Earth Information Center, which is a new initiative by NASA and 6 other federal partners to bring actionable Earth science data to people. So talk a little bit more about what I mean by that. But the first thing that I want to do is emphasize that when people think about NASA, they think about space. They think about the sun, or they think about exoplanets, or they think about other galaxies. But NASA's mission extends, in some sense, also to Earth, right? For the past 60 years, NASA has operated a fleet of Earth-observing satellites that collect data for the betterment of humankind. Juan Pablo, you made a really excellent distinction between like NOAA as being an operational organization and NASA being more of like just observing, right? Like we don't send out warnings. Like your phone doesn't vibrate because of necessarily something that a NASA satellite has seen. We partner with other agencies to help inform those models. And so we inhabit this like kind of interesting space where we observe the Earth and study it. And in so doing, we can generate these actionable data products, but in isolation, without the cooperation of our partners, it's a lot harder to actually then take action on it. So yeah, I love this graphic. There's something like 24 or so satellites and instruments that are currently in orbit. It's a little bit out of date because we are all the way up to here. So blue is supposed to be like things that have already launched. So PACE launched, God, it was like a month and a half ago, 2 months or something. And NISAR is next on the list. That's going to be sometime in October. So I was talking about these 6 other federal agencies. So NOAA and USGS are just 2 of the agencies that NASA has partnered with to build the Earth Information Center. The idea is to consolidate Earth observation data, pair it with socioeconomic data so that you can actually take action using it and put it all in one place. And so there's 2 fronts in which the EIC is trying to do that. There's one where there's this online web portal that I'm going to talk just a little bit about at the end called Earth.gov, pretty hard to forget. And then these physical, like museum type exhibits where we try and bring all this data into one place to really impact upon the public how the world is changing and how federal data can inform that and how we make decisions based off of it. So the first physical EIC opened in NASA headquarters just about a year ago. There's this wonderful photo of this big red ribbon being cut, which I thought was like, didn't actually happen in reality, but it did. What's not pictured, and so that's the official photo. So I was there, a couple rows behind the photographer. In fact, I think this guy here is the same guy there. Is that it was raining at the time, and we were all huddled in this weird tent. And there's a tarp between the tent and the rest of the EIC. It's very close crop, so you can't always believe what you see on TV. And the EIC is made up of 5 components. This museum exhibit. There's an immersive sort of like XR experience where you walk into a room and there's projection on all of the walls. There's this art installation we call the Earth Pulse, which visualizes how data flows between Earth and the Earth observing satellites. So like LED lights will light up and move upward as commands are sent up to the satellites, and then as data flows downward from the satellites, it comes down this spiral chandelier in near real time. There's a bunch of interactive kiosks where we have a growing number of interactive apps where you can explore NASA Earth science data, and then the all-important hyperwall, which I'm going to spend most of the rest of the presentation talking about. But if you're counting, that's only 4 components because I've left out the most important one, which is the worm. So outside NASA headquarters, there is now a gigantic sculpture of the NASA worm, and I can confirm that you are allowed to climb up on it and take photos if that is the sort of thing that you want to do. And so this is the Scientific Visualization Studio, or at least as many of us as we could gather at one time to go visit the EIC. And these are the visualizers who are responsible for all of the cool content that I'm going to show you in just a little bit. And indeed, there is me, and there is Mark. So we exist outside of this room too, I guess. So I was talking about the all-important hyperwall. And so what is the hyperwall? So it's a gigantic, was it like 21 feet going in headquarters, something like that, made up of these LED panels. If you look closely, you can see the seams between the panels, and there's like, I don't know, like 100, 200 something, some huge number across, and then some like, correct by aspect ratio down of these square little panels that plug in. And the idea is that there are these 2 essentially 4K resolution displays side by side. So it has this double wide aspect ratio. We were visited by Bill Nye, and he was inspired to point to El Nino, I guess. So there he is, pointing at one of our visualizations. So here is the 20-minute show that we put onto the hyperwall. If you like hold your eyelids open, you can simulate like what it's like to have all this climate data just like download it straight into your brain. But there's 3 categories of content that we put up onto the hyperwall. There are these beauty pieces, there are narrated stories, and then there are dashboards. And I'm going to break down each of those categories piece by piece in a second. So yeah, all right, I think we looked. Cool. So the beauty pieces, the idea behind the beauty pieces is that we wanted to inspire a sense of awe in visitors as they came, for them to come and see how beautiful the Earth is. And there wasn't necessarily a specific data story that we wanted people to walk away with, though I would argue in the atmospheric rivers piece and in the Dixie Fire piece, and now we have the Caldor Fire, I think, as well up there. There is like a really obvious story of like how the growth of the fire, how this atmospheric river came and hit California. But one of our most popular visualizations on the wall is just this beautiful ocean flows where it's like, say what you will about rainbow color maps, it just looks gorgeous, up there. So, again, you have to think about what your goal is when you're making a visualization. And in this case, we wanted the beauty pieces to be moments of peace and calm between all of this, peel your eyes open, download climate data into your brain. Then, interspersed between the dashboards and the beauty pieces are also these narrated stories. So these are like something on the order of like 2 to 3 minutes, documentary style content. You can see that, we'll supplement kind of like talking head human perspective with actual charts and graphics that'll like fly in on the screen in like this really nice produced way. The studio partners with actual TV producers that work for NASA to create this documentary content. And we put out a new story something like every quarter. So I think we have a new one on biodiversity that's focused on Jane Goodall and how satellite data informs preservation of chimp habitats. And then there's the greenhouse gases one is really close. I think
it's up.
It's up?
It's up now. Yeah.
Up now. We have the we have the greenhouse gases one up as well. Though I'll be honest, I don't actually know what the hook is on that story. Is it emit?
It's about controlling, I think.
Yeah, the plumes. Yeah.
EPA partner.
Yeah.
Yeah, we actually got much better with the newer one. You should see it.
Yeah.
It's really good up there. Yeah.
So Anyway, so I'm showing 3 here, but we're up to 5 at this point. But then there are the dashboards, and this is where the SVS really comes in and does what they do best to try and visualize the science behind these stories that are being told, to convey to people how the Earth is changing at different hierarchy levels. So the dashboards we have categorized kind of by theme, but also by goal. So we call this one the main dashboard, and the idea behind this is that it's kind of an entry point where you can see we have like a playlist of what you should expect to see up on the wall. It's a 20-minute show. We have a lot of people that will just come in and just stand there and watch the whole thing for 20 minutes, which is super impressive to me. So you can kind of, prep people so they know what they're going to be looking for, and then just one kind of main visualization in this hero position, just to give a flavor of the different sorts of data that NASA will that has collected in the stories that we're going to tell. And then with one supporting visualization here on the left, it looks like we're using mostly these spirals as a plot type to communicate how the temperature and the Arctic sea ice is changing. Yes, Will?
What is the hero position?
The hero position I just mean is this like gigantic centerpiece that like draws your eye and is like kind of the main focus. We also, in the main dashboard, we hope to convey, how all of this data is coming to us by actually the live positions of the satellites orbiting a globe. So that's pretty cool. Then we kind of move down in the hierarchy of specificity. So here we call this our Earth Now dashboard. Earth Now is our near real-time dashboard. So these panels are updated every 10 minutes with new satellite imagery. And then these ones, these last 2, are updated daily. The first half are like observed data that's directly coming straight down from satellites. And then the second half, the last 2, is that same data, but it's been assimilated into a model that gives us more information about like what we can't actually observe, but like the underlying model that would produce those observations. And because there's a lot going on, we tried to keep things really simple on the left and right sides. So we have, again, just sort of like a peaceful, just curated image of the day to just, show off the beauty of Earth. That's provided by the Earth Observatory. There's like an RSS feed. You can just go and put that on your phone or something if you'd like. And then on the left, we have a repeat of where the Earth observing fleet is at any given point. And then moving kind of further down the specificity hierarchy, that was the near real-time stats of just kind of like finger on the pulse, Earth mission control, what's happening on Earth. Then we start talking about the so-called climate vital signs. So we're thinking a little bit more towards the future. It's like, what are these metrics that we care about that will tell us a little bit forecasting-wise, how is our planet doing? How is it changing, and what might we expect to happen? And what is the most recent statistic that we have for that thing? And so the content on this dashboard will change on the order of like every couple of weeks, depending on when we have a new measurement of like what is the global average temperature, which I think we're getting from GISS, which is a climate modeling group at NASA. Then having kind of pointed out a couple of different climate vital signs, so things like the parts per million of specific greenhouse gases, or the change in sea level, or some change in temperature. We focus in on specific science topics. So here we start talking about just greenhouse gases in general, how they're distributed, where they're coming from, whether they're human produced, whether they're coming from like specific industries or something, and then different kinds of greenhouse gases. So really trying to give you a holistic view of what's going on with greenhouse gases. But then again, like really narrowing the funnel, talking specifically about carbon dioxide, which is this really important greenhouse gas that we do a lot to study. And in particular, I like this dashboard because I guess I should have put a movie on here. It would have looked a lot better. It's one of our.
Come see it.
Yeah, you'll have to come and see it, because this visualization in particular is, I think one of our most jaw-dropping, really, where we do this really cool 3D volumetric render with this smoke effect of how greenhouse gases are emitted. So that's sources. So this is our CO2 sources and sinks, and absorbed at different areas of the globe and from different ways. So is it being emitted through industry, or is it being absorbed into the ocean, or is it being absorbed through plant life or something? And it just is, the way the gas moves around the globe is really striking. It looks super cool, and it's really leans into what the visualization studio is good at, which is making these Hollywood production quality 3D renders of hard scientific data. And so all of that exists at NASA headquarters, and we're building a second one that should be open in October at the Smithsonian Museum of Natural History. We have one that should be opening in September at the Kennedy Space Center in Florida. But you can also find a subset. I'm working on getting all of it online, of this content composed exactly the same way as you would see it onto the hyperwall here on earth.gov. So earth.gov, as I mentioned earlier, is the virtual home of the Earth Information Center. And as it turns out, the NASA administrator really liked to stand in front of the wall when we would have important people visit and gesture at it and say, you can go to earth.gov and find all of this stuff there. And that was not true until about 3 weeks ago. And I'll remind you that this was installed last year. He was unhappy to find that that was the case. And I had been working on this prototype for what I call the hyperweb for a while, but it got pushed into prod very quickly once we got the message from the Office of Communications that it needed to be ready, especially for Earth Day, where he mentioned it a couple times during the NASA Earth Day broadcast, so that was cool. But yeah, you can go, the idea here is that you can pause, so everything moves fast, there's a lot of content. Our hope at some level is to really just give the public a flavor that NASA does Earth science, and to almost overwhelm their senses with all of the different things, and kind of hope that they focus in on one piece, and see something that they recognize, or having this digital takeaway that they'll be able to go and parse through at their own pace. As well, by posting the hyperweb online, then you can deploy new versions of the Earth Information Center with just a URL and a double wide screen, which you can start buying, from Samsung at really low cost. I'm also working on different aspect ratios, so that you could just put it on a normal screen and making it responsive. As it says here on the slide, it is not mobile friendly right now. It is a big, weird box with scroll bars if you open it on your phone. Looks great. Looks great on a computer though. Anyway, so that's the hyperweb. But that's, Earth.gov is more than just a place where you can go and look at a miniature version of the hyperwall content. What we want Earth.gov to be is a data clearinghouse that consolidates all of this data from these 7 federal agencies into one place where you can take data that is historical, looking over the entire climate record that we have, where it's relevant, near real time, and then combine that with predicted data, all in one cohesive interface, so that you can start asking questions, as simple as how many snow days have there been, in my town or in my county, and how many will there be in the future? Our intended audience for this are people that are able to articulate questions like these, but might not have the necessary GIS skills to actually do the ETL and join all of these weird data sets and then answer something that would take them like 20 minutes if they just knew R, but they don't. And so in addition to trying to gather, we have a working spreadsheet of about 84 right now, and we're aiming for a little over 100 data sets over these 9 different, they're called Earth action themes that NASA is trying to focus. In addition to gathering this data and then just making it available, that like, oh sure, just freaking hit our API and open a Jupyter notebook or whatever. Like that's not helpful for people that don't have that skill set. We want to also provide a comprehensive interactive analysis and visualization tool where you can go have a map where you can toggle different layers, draw stuff on, and start making some of these summary charts where you can answer questions like how many snow days has my town had over the past 100 years, and how many will we have in the next 100 years. For example, like if you're a high school student doing some kind of science fair project, or some of the other audiences that we've targeted when we sat down and we did our Miro whiteboarding. It's like data journalists, congressional staffers, local politicians, etc., nonprofits. So yeah, this is all stuff that's currently in progress. Our plan is to have all of this data, once it is available for people who do have GIS experience, it should also be discoverable through ArcGIS image and feature services. So you'll be able to just pull it right into whatever you're used to using if you don't want to use our little app. And we're hoping to have all of this ready to go by October. And I think we're on track to do so. We just finished our scope setting and budgeting planning, and going to get 2 interns over the summer, and we're going to be a crack team, and we're just going to bang it out. But I think with that, I will say please stay tuned. I really want to come back once Earth.gov is stood up and there's something to do. Maybe we could do some kind of like data hack viz thing where we have like all the data sets and people can make cool stuff. I'm speaking for, I have not mentioned this to them. I'm just spitballing something. But I definitely want to come back, and y'all are also in some sense the intended audience as people who maybe can ask earth science questions, but maybe aren't necessarily equipped to answer them immediately. So yeah, please stay tuned, and I guess with whatever time I have left, I'll answer some questions.
We're actually a little over time, so if you have questions for Alex, you can find him at the end. Want to leave a chance for our one lightning presenter. Thanks all for hanging on. Yeah.
Did you have 2? Or?
We did have 2. I haven't seen our other one, who was going to come today. So.
Okay. Cool. Yep.
Oh. Puni, are you here?
Oh, maybe hiding over there.
I'll take a look.
Okay.
Yep. Okay. Also, we will at some point, allegedly October, do a field trip to when the thing is
the
open.
Smithsonian.
Yeah.
It's open on the weekends, whereas NASA headquarters is not.
Yeah.
So we can't do a field trip.
All right, I know it's late. I'll just try to show you some stuff real fast. Okay. Hi, I'm Mark.
Hi, Mark.
Boy, I thought that was going to play. So one big, we'll talk about climate change. Every January, mid-January, NOAA and NASA get together and have a joint press release where we announce the average global temperature for the year. We collect that global temperature using the same measurements. These are measurements over the ocean and the land. These show the measurements that went in the 2023 temperature. And then we put them together to give you one number, which is how hot the planet is over time. Of course, we haven't always had that many temperature measurements. NASA sets its record back to 1880, and you see, like, well, we've got a lot more now than we used to. But still, you don't actually need that many to get a global temperature. So we feel like since 1880, our errors have gone down. We've been able to do a decent job of that. And 2023 was by far the warmest year on record, as you've heard, I'm sure. Some different ways to visualize that. This is something we call the NASA climate spiral. It's sort of, the radial plot was based off of something that Ed Hawkins did way back when, and took a little twist on that quite literally to turn it, to do it three-dimensionally. A lot of the data viz our group does is naturally, we tend to work in rendered 3D graphics, so kind of naturally, that sort of surprise twist, maybe you've seen this on social media, so it turns into this sort of linear plot. So I'm just going to show you some of these more simple graphics we do. We're really known for the big kind of data viz that Alex was describing, but one of the things, last June, we actually had the hottest monthly temperature ever. And it's the hottest monthly temperature because some months are actually warmer globally than average. I know when it's summer here, it's winter in the southern hemisphere because there's more land in the north. There's a bias towards summer, and so we wanted to be able to show that. So this is a different kind of plot that takes in that, shows you that monthly pattern. Of course, all that is, this is the same temperature record. So the point, I'm trying to go fast for you. The point is that many ways of visualizing the same data. This is a relatively simple data set. It's a low resolution data set, but these are different ways of picking out different kinds of information. So this is what that data record looks like on a map. And as you'll see, as Juan Pablo showed you, that warming is happening preferentially in the Arctic. We also see that this is what my question was about. We've made this graph for many, many years. We've used this -2 to 2C, which worked for a while, and it's not working this year at all. So we're gonna have to change it, which is sad. Here's another way to look at that same data, because you see, let's not just look at the mean temperature, but the distribution of temperatures. And we call this the climate jellyfish. You see there's this weird bobbing back and forth. This bobbing back and forth, I actually didn't know the first year I made it, till I forget about it, but that's the El Nino La Nina cycle, the exchange of heat between the sort of ocean and the atmosphere. And you see two things have happened. One, we've gotten warmer, but that distribution has broadened. And there are two ways, the two things that can mean. Does it mean that every place is seeing more variation in temperature, or it could be that some places are warming faster than others. In fact, it's primarily the second explanation. Here's another visualization to get at that, where we've now broken up the Earth into latitude zones, and we're kind of looking like sort of graphic equalizer of how each of these different bands of the Earth is changing its temperature over time, and you're kind of following them. And what you will see, certainly recently, where now that warming's really beginning to pick up, is that the Arctic will be warming considerably faster than the rest of the planet. We can do these kinds of visualizations with other climate indicators. In particular, this is one of these real-time type visualizations similar to what Juan Pablo was showing you, the Arctic and the Antarctic together. You see they have sort of opposite cycles. In September, the Arctic reaches its maximum, or Antarctic its minimum, and vice versa. Arctic is actually a better tracker a more reliable tracker of climate change because it's related to the geography, the different geography of the Arctic and the Antarctic. And so here is doing that same spiral type treatment, but with the Arctic sea ice extent. And here you actually see that we actually have a seasonal pattern. And in fact, if we cut it in half, you can see on one side, we have the Arctic sea ice minimum, which we're plotting here. And in the other, we're plotting the Arctic sea ice maximum. Both are decreasing. We see that this plot I just added after listening to C's great talk. This is showing you a map of droughts and floods. And it's using data from the gray satellite, which actually measures the gravity. And if there's a lot of water, there's more gravity. If there's less water, there's less gravity. And it's showing the intensity of these. You're seeing 5 years at a time. You see, as we get both the amount and the intensity, which is the size of those bubbles, are increasing. We're trying to make the bubbles look wet or dry, hopefully. But you see just how much, and that's just one of the stories of climate change is the wet areas are getting wetter, dry areas are getting drier. The people who study sea level were getting jealous about how much attention on social media the little graphics were getting, so they wanted their own. So this was an attempt for the annual. You see, once again, the sea level rise last year was the hardest record. NASA's a 30-year record of sea level rise, and here's a graph showing that. So the idea is, let me play that again for you. This is doing the same kind of trick to show both a seasonal pattern. These kinds of charts have become very popular. I don't have a good name. I think Tufte keeps trying to name this kind of graph, but it's not consistent. And then by turning it to the side, you can go from the monthly pattern to see the yearly pattern. And another way we visualize that data for the Earth Information Center, where we have that physical display, was actually to put it at a 1-to-1 scale. And those circular portals that Alex described, we were sitting there and we're like, you know, it's kind of like you're looking at a ship's window. What if we pretended you're looking at a ship's window and watching that 30 years of sea level rise? And so we made this, which is kind of fun. And if you go there, 1 inch is 1 inch. It just keeps going up, in case you're wondering how it finishes. I just say, like, everything we do, all 9,600 and something visualizations are freely available and at that second website. And come check it out, use it, and come by the EIC. Thank you.
And one last short presentation. I do have to ask, for the rotating visualizations, where you like had the line and then it rotated, what technology is that built in?
So this built in Houdini, which is a 3D modeling program. The trick is that it's all built in 3D, and I'm using an orthographic camera. So the third dimension, so one dimension is month, one dimension is year, and we kind of just rotate like that.
That's cool.
Riveting stuff, I know.
Looks like the slide didn't load.
Okay. This will be interesting. Oh, so wait, what exactly didn't load? I'm not entirely sure.
It'll be a surprise.
Find out. All right. Well. All right. Well, hopefully nothing goes wrong, but if it does, then at least we'll get a few laughs out of this before we head over to the happy hour. So first off, happy Earth Day to you all again, and thanks to Will and Jill for giving folks in the community who have an interest in earth science and climate change a chance to kind of share some of their talents and knowledge. And since you've already heard from a few different people who have shown off some really impressive visualizations so far, and really spoken to various aspects of Earth and climate, I thought I'd do something a little bit different, and that is to kind of speak to a call to action in a way. I kind of want you all to walk out of here with something in mind, which is how you all can go home and use your own visualizations in order to get folks whom you may know, who may not be totally sold on the idea of climate change, or who may just need more information. I hope to, inspire you all to some degree, as much as I can in 10 minutes, to educate other people you may know, to use certain kinds of visualizations. In my case, I like to use maps, but it really doesn't matter. It's more about the why of what you're doing, not the actual what. So, as I mentioned, I'm hoping to kind of make this a bit of a call to action. And so on Earth Day, we're having this event not just because we want to better understand the threats facing our planet, but also we want to inspire folks to take action on it. And we believe that data visualization can be a great tool for that. And so why do I like maps for some things? Well, maps allow us to take an issue that's quite global and make them more local in nature. I was inspired to do this because climate change is kind of a unique problem, as you all are well aware. Americans and really people across the globe have some paradoxical beliefs about this. I'm not going to go through these in detail for the sake of time, but you can see a bit of a paradox here between the fact that people believe that climate change is real, and most of them even that humans are causing it, but they're not necessarily prioritizing it. They don't necessarily, want to take action on it right now, or they may just feel a bit indifferent about it. And as you can see here, climate change routinely ranks toward the bottom of folks' lists of more important political issues, or excuse me, most important political issues. And it sort of has led me to, somewhat in jest, but also as a bit of a, hopefully give you a bit of a chuckle here, but I couldn't help myself, had to include a meme, right? So why is there this disconnect? And the answer to that is, I would argue to at least some degree, there's something psychological going on here. There's a bit of a distance factor. It feels distant, climate change does. Even though on some level we know that it's happening or it is going to happen, it nonetheless does not register in our brains. Our brains aren't really wired for climate change, unfortunately. Knowing about climate change alone does not really get us where we want to go. On some level, we need to be able to feel climate change. So it's not even the amount of information. It's about what kind of information you're giving them and how it makes people feel. And that's really what separates what we know and think from what we do. That's kind of how we get there. It's emotion. So our emotions dictate our motivations. Our motivations dictate our decisions, and our decisions dictate our actions. And distance, this idea that climate change feels kind of out there, abstract. That, I think, is a key factor here in explaining why it is that people don't necessarily feel it as viscerally or don't prioritize it as high. And this is, I think, a byproduct of how we evolved. Things that are in our environment that we feel are very close by are much more likely to register with us and get us acting toward them. Now, humans have an ability to some degree to look toward the future, to look toward distant phenomena and things. And that's what separates us from other species. We have at least some capacity to do that. But even that is somewhat limited. So then if we want to get ourselves acting toward climate change, we need to bring it closer, as I will explain in just a minute. So what does closeness even mean here? And here are just a few examples. Not just talking about how close it is, in the room, for instance, your neighbor's right next to you, but I'm talking more broadly, across time, across your social networks, psychologically. And so I think what I'm trying to get at here is that you can't really just replace your brain. I mean, that's not going to work unless we have some crazy space age technology that I'm not aware of. But what we can do is try and bring climate change closer to us, to the brains that we do have, reverse engineering it to some degree. And so going back to that original diagram, and of course I'm going to focus on the spatial component here because of the maps, but you can sort of see some examples of how you might do that. So for the example of socially, you want to bring in trusted messengers to deliver messages on climate change, because a lot of folks, they have a disdain for scientists, unfortunately. That's just the reality of it. Bring the consequences that are in the future and try and explain to them what it means here and now. And that last one here is the here of the here and now, the spatial part of it. And just to kind of reiterate why I like to use maps. So we can bring these global, distant, abstract phenomena and consequences back toward us. That way they feel more visceral and real, and that they can also put very complex information out there in a way that we can understand. And that is much more likely to get people to act. And so when I take a look at climate impacts, for instance, one of my favorite tools is Probable Futures. Probable Futures, they produce a variety of different maps. This is actually pretty easy to use. If you want to go up to a Probable Futures website, you can Google it. You can probably recreate this map in a matter of 10 minutes. This is one of my favorites, and this right here allows me to tell a story about climate change's impacts. I decided I would take a look at extreme heat because DC, you know, we get really brutal summers here. And unfortunately, they're just going to keep getting worse. So this specific map here, it shows you know, the number of days above 35 degrees under various warming scenarios. That's 35 degrees Celsius. And that legend at the top, of course, shows you the number of days per year. I'm sorry if it's a bit fuzzy, but it goes from 0 on the low side all the way up to, it looks like, in that magenta colors, goes all the way to 365 actually, but we don't get anywhere close to that, thankfully. But here's what it looks like under 1 degree of warming, which is more or less where we are right now. 1 degree of warming is roughly what we've had. And we want to keep it under 1.5 if possible, but it's looking like we may overshoot that a bit. What happens if we go too far? Well, this next one shows you an extreme case, under 3 degrees Celsius of warming. Look at the expected range of outcomes in terms of how that changed. We went from 15 days per year in terms of days above 95 degrees Fahrenheit to 36 of those. That is mind-boggling. And yeah, I can see folks like, ooh, that's hot. So, you know, there's other tools out there that you can use to map any other aspect of extreme heat. This one, this animated GIF that I can, unfortunately, it's not showing up as big as I'd like, but you can see the explanation there. The number of extreme heat days above 90 degrees between, you know, 1979 and 2019 each summer. And you can see that trend over time is you're seeing the heat sort of spread, if that is actually displaying correctly. And I'm not sure if it is, unfortunately. I think that might have been the source of the error message, unfortunately. So some of the, yeah, that's unfortunate. It's not quite displaying properly, but it's okay. In any event, I tried to sort of crudely recreate that same map in Python. And once again, unfortunately, some of the legends are not showing up very well here. But I think the broader point here is just to take a look at that shift. The redder that you see the area, the more days above 90 degrees that you're going to get. And that's sort of what we have historically between 1979 and 2019. You can see just how many of those days we are starting to get. And of course, as you go up the scale, the red really will show you just how many more days. So red is more, as you would expect. And Texas really jumps out on this map. So if you're planning to move to Texas, well, good luck. You're going to need it, I think. So, but what about solutions? Because people don't just want to feel doom and gloom. They want to feel like they actually have a shot at making a difference in their local communities. And if you can highlight something on a map to where people can get involved, where they can raise their voice, then you could potentially give them a feeling of hope and power over this. And one example I want to show you here from this group called Climate Cabinet, they actually have a map here, or a mapping app that one of their data specialists made, where he was actually able to put a bunch of data on older fossil fuel power plants onto a mapping app. And so you can go onto this and find, okay, here are some really old fossil fuel power plants. These are prime targets for retirement. If you can get those shut down by raising your voice, then you might be able to say, hey, I made an impact here. And you can see the one that's highlighted on this map is actually not too far away from here. It's southeast of DC, the Chalk Point power plant. Again, this is a plant that's been that's been online for at least 30 years. And this is, again, a prime role where we can give people information that they can use to act. So, of course, maps have limitations. There's no secret to that. You can certainly correct for this to some degree. But again, there are a number of limitations. So you shouldn't use maps as a be-all, end-all. There is no silver bullet here, unfortunately. No data visualization tool is a silver bullet. I wish that was the case, but there simply isn't. So population density is a big one. I'm not sure how many of you saw in the wake of the 2020 election when folks were sharing that map of look at all these red areas, like all this land that's red, even though the votes came back and of course they were overwhelmingly blue. Well, that's kind of an illustration of that. And so cartograms, you can correct for that to some degree, but it ends up not being as intuitive because you end up distorting the map. Cartograms basically adjust for the population by distorting the land area. And they can be useful, but you have to be really careful. And of course, maps offer a snapshot. You can string together a bunch of snapshots into a GIF or something like that if you want to capture time. Otherwise, showing like a change in some value over a different interval of time, of course, you can use maps for that, but that's just another limitation that's inherent to map making. And of course, no visualizations are going to be self-explanatory in general. You want to make sure you got at least some decent color scheme or legend. You know, unlike that crude chart that I made a few slides back, but you get the point. Visualizations don't, you know, speak for themselves. They need to be made part of a story. That's something that I did for a number of years, was tell stories. And that's kind of one of the messages I want to leave you all with, which is that we all have a role to play here, no matter what background we come from. And so the climate crisis, as I was mentioning, it is the consummate challenge of delayed abstract consequences, and it's not something that really works well with our brains. But we do all have the power to use our talents to get people high quality information that not only informs, but connects with them and gets them inspired to take action. And maps, of course, I view that as one way that you can bring climate change closer to home in a way. That's kind of what I want to leave you with. Bring it closer to home, use it to tell a story about what has happened and what will happen and how people can find their voice in their communities. So with that, I just want to say thank you so much, and I don't want to keep you all from your happy hour, so.
Thank you very much. So a couple of closing remarks and housekeeping notes. Logistics, after this, people often head across the street to Courthouse Social, literally just across the street, to have a drink, keep the conversation going. So hope to see some of you there. Second, I want to say a big thank you to Jamal for taking the point in organizing this event, though it was a team effort. One more round of applause to our speakers. These were awesome presentations. And then just a note, we saw a lot of Data Viz on climate change, and we've got some issues to work on. And I know it could be easy, like Benit was saying, to feel discouraged, but I think that we should leave here inspired, not just to do more Data Viz, but to take action and feel like it's gonna be okay, because we just saw data from hundreds of satellites. We have more tools and technologies and capability to solve and mitigate climate change than we've ever had before. So I think there is a case for optimism. So with that, thank you all for coming.